This is the continuation of 9.4. Unfortunately, I had to cut the other one short because I ran out of room. We only had one example left to go. How annoying. Oh well. That's life. So this one, last example, sigma n equals 1 to infinity of n plus 2 over n plus 1 quantity cubed. Okay. So our a sub n, our given problem is a sub n is n plus 2 over n plus 1 quantity cubed. If n is 1 or bigger, that's positive. I'll write that in just a second. And b sub n, if we strip away all the lower powers, well, let me say it differently. If I strip away that constant of plus 2, I'm left with n. If I strip away the constant, that plus 1 inside the parentheses, I'm left with n that's cubed. And then simplifying, that's 1 over n squared. So a sub n and b sub n are all terms of those series will be positive, so that allows us to enter the comparison tests. So as I said, we're kind of making an assumption that comparison. All right, so the first thing we have to do after we've established what a sub n and b sub n are, and we've established that they both have positive terms only, we then have to talk about the series for b sub n, the simple one that we're comparing to. So what kind of series is this? Right, it's a p-series. And what's the value of p? It's 2, right? So since p in this problem is greater than 1, what does that mean about the series? Well, it means that sigma b sub n converges. All right, so we've established the convergence of our series that we're comparing to. So now we set up the limit of the ratio of those two general terms, a sub n, which is n plus 2, over n plus 1 cubed, divided by b sub n, which is 1 over n squared, all right. Then algebraically, dividing by a fraction means multiplying by a reciprocal. So we'll end up getting, when we do that, n squared times n plus 2 over n plus 1 cubed. Okay, so let's see. We're going to have to do some algebra here. Let's see, distribution of n squared makes it n cubed plus 2n squared. And then if I cube n plus 1, I get n cubed plus 3n squared plus 3n plus 1. You all should be able to cube binomials. You should be able to raise binomials to the 4th power or 5th power, because in pre-calculus you did the binomial theorem. If you need for me to talk about this during class, I'm happy to do so. For right now, I'm just going to say you should know how to do what we just did. So now this is a polynomial over a polynomial, And the trick with those is to find the highest power of n in the denominator and multiply by the reciprocal of that highest power over itself is a form of 1. In the denominator, the highest power of n is 3, so I'm going to multiply by the reciprocal of n cubed over itself is a form of 1. Distributing the 1 over n cubed, I'll get 1 plus 2 over n divided by 1 plus 3 over n plus 3 over n squared plus 1 over n cubed. This down a little bit. Okay. So the limit of a constant is that constant. The limit of any constant over a power of n as n goes to infinity will be 0. And so that's going to be 1 plus 0 over 1 plus 0 plus 0 plus 0, which is 1. Okay, we've done the limit. So what? Well, you have to remember that what you're looking for is once that limit is done, the only way we can proceed is if that's a finite and positive number, and it is. And you're going to tell me you thought about that by saying, oh yeah, that's positive. And if it's a real number, I know it's finite, so you don't have to say and finite. It's enough for me if you just write greater than 0. And so, because we did get that finite and positive answer, we can conclude that the series they ask us to work on this time, which was n plus 2 over n plus 1 quantity cubed, also does what? Well, it does whatever the one we compared it to did. You may have forgotten what that was. So let me go back up there and look at it. We compared it to 1 over n squared, and 1 over n squared is the p-series that converges. So that means that our series also converges by what test? Please don't forget to write the name of the test. That's a big part of your answer. It's by limit comparison. Okay, so that's the end of the notes for this section. Have a great day, and I will see you in class.